This is a test. This is a test run. I've invited Josh from the science classroom to do some experiments with me today. So we're gonna do some side-by-side experiments.
Hey everyone.
Yeah, there's Josh from the science classroom.
Yeah.
I'm gonna go ahead and get this set up.
What are you doing here, Tom?
Well, I do what I normally do, right? So I got a little stir plate going. You can see I got the stir bar going.
Yep.
Then I'm gonna pop some essential water in there. You notice essential water, the pH quality, it'll say it's like 9.5 or higher. It's a little hard to see right there. So we're going to put some essential water into this flask. This is the old standby, but we got a lot of extra experiments for you today.
Yeah, I'm getting ready. You can see there's my my preview here. I got my vacuum chamber.
I cannot wait. I cannot wait.
Got my vacuum chamber set up. This is what I mostly do right now.
Yeah.
Put stuff in a vacuum chamber.
You're leaning into the vacuum chamber hard, huh?
Yeah, it's I never actually had a viral video until I started using the vacuum chamber.
Yep. Yeah, if you haven't seen the science classroom, you definitely want to go over to that channel and check it out. He's got some crazy cool videos with a vacuum chamber, really creative stuff. So Isfan says the voice is lagging. Thanks for letting us know. I apologize about that. There's nothing I can do about it though. Okay, so I've got my my essential water set up. I'm going to start adding some universal indicator up there at the top. Look at that beautiful purple color going in.
Oh, nice.
Yeah, and you notice how it kind of stays centered in the center of the vortex.
That's so pretty.
Do you know why that is?
Why it stays in there?
Huh?
Intermolecular forces.
Well, I'll try again. Hello there, Josh. How you doing? Good to see you, Josh. Here, we'll try again. I'm going to put a little bit of that stuff in there.
Look at that. Wow.
Yep.
Why? I don't know. Why is it staying in there?
Just like the eye of a hurricane is low pressure.
Okay.
The eye of this vortex is low pressure. And certainly material, gases and liquids, move from high pressure to low pressure. And once they're in the lowest pressure region, they just stay there. They just sit there. So there you go. In the eye of the vortex is low pressure. So when you put material in there, it tends to stay in there. Now, of course, once it gets down to the bottom, it hits a stir bar and then it gets pushed out along the sides.
Well, you're giving me an idea.
Yeah.
I want to see if I can put a vortex in my vacuum chamber.
Come on, man.
I need a battery operated stir plate is what I need.
Yeah.
I can do that. And I'm sure they have those. So I got to find one.
Here's the deal though. I don't think would the vacuum chamber change the pressure in the fluid? Not that much. Although who knows, right? Just give it, who knows? Who knows what kind of crazy stuff you're going to see.
Yeah, I don't know. I'm interested. I don't even know if a vortex could form in a vacuum.
Oh, that's interesting.
I'm curious about that.
Well, great. We're going to have to see that.
You guys will have to follow me because that'll come. That'll be on the channel soon. I'll test that.
I'm looking forward to that. You're also going to be testing something else today here, right? In your chamber with club soda.
Yeah. We're gonna do some pH measurements with universal indicator. So go ahead, Tom. What are you gonna do here?
Well, here let's remind folks of what we're doing here with this experiment. So I'm gonna go ahead and get my pH indicator slide up here so we can recognize indeed that the flask has violet. Oh, we're gonna let you know, Classic. We're gonna be doing some vacuum chamber stuff. You're gonna love it. I hope you're gonna love it. We're gonna be doing some tests. Anyways, in this flask right now, you can see it's violet in color, which indicates pH 10. And I'm gonna add some hydrochloric acid. This is the same acid that's found in your stomach. It's just 1,000 to 100 to 1,000 times more concentrated. So I'm gonna add a drop. And as you can see, when you add, there it is. When you add acid to something, the pH drops. How do you know the pH drops? Because the color's changing. Got a little flash of rainbow there, which is always kind of nice. But,
That's
you know, we start
beautiful.
out at a pH of 10, and it looks like we're relaxing at a pH of 7 or so, maybe 8. No, it looks like pH 7, so it's neutral. The acid and base in this system are completely balanced. If I continue to add some acid, as you can see me doing up here at the top, then that color shifts to red, and that's going to indicate a pH of 3. So that's what we do here. Then we'll add a little bit of sodium hydroxide base, and hopefully we'll catch the rainbow. Come on, baby. I think I may have added too much base.
That still looks pretty great though. Look at that. That's nice. Oh, you're getting some green. Look at up top.
Oh
Yeah.
yeah, we got a little flash of the rainbow. I'm gonna try again here,
Beautiful.
Josh. I usually pull it to acidic. So there's back to acidic. I'm gonna just try adding 1 drop of base this time. Let me just try 1 drop. I also think I should probably add some more universal indicator. We need just a bit more color. Come on, rainbow, let's get it.
There. Oh, nice.
I'm gonna cheat and add a little drop there, maybe. Come on. Yeah, not too bad.
Oh, that's nice right there. That's good.
Hey, Classic, are you still hanging out? You still hanging out there with us, Classic? Let us know. Because we might get started doing the vacuum chamber stuff here.
Yeah. Why don't should I? Maybe I'll add some universal indicator here to my
Yeah, let's do it.
to my bottle.
I'm gonna flip around and watch. All right.
So I've got some club soda here, which is basically just it's basically just carbonated water. You can see there's not much added here, but I think the big difference here is it's also has minerals in it, club soda. So it's a little different than like normal just fizzy water. So we've got, I'm just looking at the ingredients. We've got, it's carbonated water. It's got potassium bicarbonate, potassium sulfate.
Huh.
So I'll open this up. We'll hear the hiss. See that carbonation come out.
Oh yeah. Hey, let's see if we got any chemists in the chat. So potassium bicarbonate and potassium sulfate. What are those in terms of acidic, basic, or neutral salts? Does anyone know? Anybody?
This is a good question.
Yeah, it is a good question. Go, keep going, Josh. I'll read the comments as they come through. Keep going.
What I think is interesting about this, I don't know what color it's going to change. Tom, you've done this,
Yep.
but carbonated water and potassium bicarbonate. I'm going to give the answer here because carbonated water is acidic.
Hey, hold on a sec. Check out Classic in the comments.
Classic.
We've got a
You're right. You're right.
Chat. Come on, Classic.
All right. Potassium bicarb.
Yep.
That's basic. So let's see what color this changes here when I add the indicator.
Let's remember our pH scale.
I'm going to have to kind of shake it up a bit here.
Oh, yeah. Got a little universal indicator in there.
You're seeing a little bit of red color. Oosh. All right.
Hey,
so we got acidic.
I think you do. Add a little more, Josh. Add a little more. I want to see the color pop a bit. Put it in there. Let's make that thing. So wait a minute.
I'm running low.
Hey, thank Noah's. I appreciate that. Noah's. Noah's liking my shirt.
Oh, it is a good shirt.
So now wait a minute. We've got basic salts in there, and yet the pH is showing red, pH 3. What gives, Josh? What's going on in there?
Well, what I think's happening here, I'm going to take this off so we can see it better. But that dissolved carbon dioxide reacts with the water to form an acid.
Oh yeah.
Right? Carbonic acid, isn't it? Carbonic acid?
It sure is. It sure is.
Let's get some more in here. Now here's what I'm thinking. Now Tom was making his solution there go acidic and basic by adding acid and base. Right? So look at that. Basically same color we got. Both got acid.
I'm going to add a little more universal indicator in mine, make it look more pretty.
So here's what I'm thinking. And Tom really had this idea. So I just haven't tested it yet. We've never done this. So what I'm thinking is if I could get all the CO2, because the CO2 is the thing that's making this acidic, if we get the CO2 out, will it change to green or even blue, turning basic?
Well, wait a minute. How are you going to get the CO2 out of there?
All right, there now the vacuum chamber. This is what I do. Check out my channel. I do a lot with this thing. When well, I'm going to stick it in here. When I put this in the vacuum chamber, what I can do now is I can suck the air out of this chamber.
Yeah.
And the pressure is going to drop inside of here. And when the pressure drops, you're going to see it. I'll even zoom in here. That it'll start really bubbling all that CO2 right out of that solution. You'll see it bubble like crazy.
So it's going to take the carbon dioxide out of the soda water.
We're going to suck the carbon dioxide right out of there. And remember, that's what's making it basic. So, or acidic, sorry. That's what's making it acidic. So it should maybe
Hold on before
basic.
you do it. Hold on.
What do you got?
We need a control. You got to take some of that out. You got to take some of that out and not. Oh yeah, we got it.
Can I do this?
My apologies. I'm so sorry.
No. You're right. You're right. Oh. All right.
All right. So
here's that.
hello,
Tom's right.
Owen. Owen saying hi.
Hey, Owen.
So you're adding universal indicator to club soda.
This is the same thing right here.
The color is turning red, which is indicating an acid because of the carbon dioxide that's in it. Yeah?
How is that? How is that set? Maybe I should do this. I'll move this to the side more.
Yeah, it's good. Hello, Alicia. Welcome aboard. We are doing an experiment we've never seen before, and we hope. Well, that's right. In science, we're never supposed to hope. We're just supposed to observe.
All right, so let's get these side by side. You're absolutely right. We got to have a good control.
Yep.
All right. What does everyone think? Does that look pretty good? I don't like how that one's lower, but it's just, you know, as you make a lot of YouTube videos, you're always looking at the look of the video. But that's okay.
All right, man. This is live. They don't care. They just want to have a good time.
All right, here we go. I'm gonna turn the pump on. It is a little noisy, but hopefully you can still hear it.
Thomas.
Thanks, Owen. You think it looks great? All right, here we go. Let's switch it on. We're going to start taking that CO2 out.
Is it on?
Yeah, can you hear it?
I can't even hear it.
Well, you know what? Come on, vacuum pump. My pump's having a little trouble. Hang on. There it goes. There it goes. Okay, here we go. See it drop in?
Oh yeah, you see the bubbles?
Look at the CO2 coming out of there.
Come on, man. I don't see a color shift yet.
It's got to change. It's gonna take a while, I think.
So yeah, look at that carbon dioxide just coming out like crazy. This is Henry's law in action, right?
Yeah, it's Henry's law. As pressure goes down, solubility of gases decreases.
Sure.
Right?
Oh yeah.
Now, if this doesn't work, I got a backup plan.
Well, I'm wondering if we can stick a nucleating stone in there or something to help it.
Yeah.
Not like I don't know, like a pebble or something.
Yeah, that's not a bad idea.
You know what? I'm seeing a color change. That thing looks more orange to me, but it may be me wanting to see the change, which is why you always need control.
We got to hold it up a little bit.
Come on, man. Classic seeing it too. I think it's a little more orange. I totally do.
You know what I need to do? I need to drop my camera a little bit.
Okay.
Because we need a more white background here.
Yep. Hey, but folks, you got to all help me now because I'm one of these scientists who, like, I am very exuberant and I love to see differences.
That looks different.
I'm seeing a difference, but I need to make sure that what I'm seeing is correct, which is why we do this in science. We ask other people. We rely on each other to make sure that we're not fooling ourselves. What was it, Feynman, who said that? the first principle. Richard Feynman, probably the greatest scientist in American history, United States history, said, when doing science, the first principle is you must not fool yourself. But you are the person most easily fooled. And I really try to remember that all the time when I'm doing experiments. But what do you think, folks? Give me a thumbs up if you think it looks like there's been a color change. Give me a thumbs down if you're like, nope, this old guy doesn't know what he's seeing. Let's see what they say in the comments. Josh, you
Yeah,
giving me a thumbs
I'm
up or a thumbs
interested.
down? I'm
Here,
giving it a thumbs up, baby. But that
I
doesn't mean you got to agree with me. Josh, what are you thinking?
here I see a color change, but here's what I want to do. I want to I've got some other bottles here in a warm water bath
Ah.
because as the temperature of a solution increases, the solubility of gases decreases. So hotter water can hold less gas.
All right, Genius Josh has entered the chat.
So what I'm thinking here is that if we try this again
Yep.
with warmer water, we might get a more substantial color change.
Hey, a couple things here,
I'm not
Josh.
convinced. To be honest, I'm not convinced that that's a color change.
Classic gave us a thumbs up. Richard Waddle said, yeah, they think it's a little more orange. And TM has a great suggestion. TM wants you to gently mix the control bottle for a better
Yeah,
comparison.
we got a lot of color on the top.
Hello, life is good. What's going on? Thank you, TM, for that suggestion. Come on, man. Come on, man. That's totally a color change.
It looks different. It does look different.
I think
I don't know.
so.
I'm just. Hey, Tom, can you hold up your pH?
Yeah, let's do it. Let's do
Your
it.
scale.
Yep.
Hold that scale up there. I mean, you basically got the scale. Okay, there we go.
TM is giving us a thumbs down.
Yeah,
Well, that's
TM.
all right. Hey, that's okay. We got a little bit of a disagreement here. I think you might have a bit more indicator in the sample in the vacuum.
All right, I'm letting the pressure back in.
Okay.
Here,
Yeah, let's do a real side by side comparison there, bud. Classic saying 4 to 5. Come on, man. Look at that. That's totally a
There's a little
difference. Well, I don't
condensation
know.
that's built up.
Hold it up against that white background, buddy.
Ooh, I don't know.
I think it's there. Add a little bit more indicator to the one on the left. Earthy is saying no way. Ha ha. They're laughing. Ha ha. I wish.
Where's the top? Here we go. I think it could be different, but we got to try it with the warm. We got to
Yeah,
try
let's
it
do
with
it
the
with the
warm.
warm. Owen is saying different for sure. I think those are roughly the same shade. The same,
They're the same intensity. That,
that is
yeah,
slight.
very slight difference.
Hyohyun is saying it has changed. I'm gonna go back. I'm gonna look through the comments and see what the votes are. All right.
Okay, I'm gonna set up for the next one here.
All right. Let's see. I'll flip this around so folks can see me counting here. Josh, are you giving it a thumbs up?
No,
All right.
I'm giving it this thumb
So
sideways.
Josh is abstaining. Abstentions are perfectly fine. Classic says thumbs up. TM says thumbs down. Owen said different. Hyohyun said different. Life is good said one is more clear. So I think I can't interpret that as yes or no. TM thinks he had more indicator in the control.
Okay. Woo.
I'm saying yes. So it's 4 to 1 to 1 abstention. You like that shirt, Earthy? Come on now. So yeah, right now it's 4 to 1 to 1. So tell us what you're doing now, Josh. What are you
Here's
doing
my
now?
limiting. I want everyone to know though that I'm conserving universal indicator. Stupid me. I left my big bottles in the lab. I'm not in the lab. So
Yep.
we're gonna do our best here. So I'll try my best, everyone. I'm gonna add equal amounts here to our control and then our experiment.
All right.
And let's see, for perspective here, we can see the temperature of these things.
Yeah.
This is Fahrenheit.
Come on, man. True American patriots use Kelvin or Celsius. What are you doing in Fahrenheit?
I just
Oh,
bought
you're
this.
Canadian. That's right.
All right, there. That's better, right? 34,
Yeah, there you go.
34 degrees. And then our previous experiment was look at that.
Yeah, big difference. Okay.
Yeah, that's too cold for
Hey,
you
I
American.
want to just pause you here for a bit. So
Okay.
Dylan Sterling had a really nice suggestion. Unfortunately, I don't think we're going to be able to do it this live, but Dylan said, "Hey, why don't you mix the full batch and then bottle both after? So you add the indicator liquid and you mix all that into one batch, and then you split it into two, and you're going to put one in the chamber and then leave one out. That's a great suggestion, really.
You want me to do it?
Well, here's the deal. We're going to lose some CO2 when we do the pouring. That's the issue.
We will.
So it's there's a lot going on there, right? It's a difficult. You know what? I think this is what I would do. I would make sure you add the same number of drops to both bottle. I think that's probably the best compromise. Yeah.
Okay.
All
Let's
right.
do that.
What do you
Let's
think?
do
I
that.
mean, what do you think?
Well, if it wasn't for my lack of universal indicator, I would be very bold and I would dump a bunch in.
Yeah, right. All right. How many? Let's see how much you got again.
What do people think? Should we go with Dylan's idea? Here's Dylan's idea.
Good call, man.
Here's Dylan's idea is I dump, this will save my indicator too. I'll dump indicator in this one. And then I've got my little glasses here. I'll just fill these up equal and I'll put one in the chamber. I'll leave one out. Or, so that's Dylan's idea. I like it. Or I do 2 separate bottles again.
It looks like people are saying Dylan's idea. So scrap what I'm saying. I
All right.
apologize, folks. We've got a better experimental design with Dylan. Dylan, thank you for correcting this PhD chemist. I love it, man. I love it.
And I only have a master's in chemistry, so I don't.
There you go, man. I'm the odd one out. Shows you
All
what
right,
my
here we go.
Michigan degree did for me.
Well, hey, it doesn't matter. It doesn't matter how much I add, right? Well,
no,
let's wait. What's Dylan got? Dylan.
Yeah. Come on, Dylan.
Preheat the glass.
So while you're doing this, Josh, Zaj asked, "Hey, what's the experiment?"
Good. Yeah, we should explain that. Can you do that while I'm setting this up?
Yeah, sure. So what we're doing here is we are adding universal indicator to some club soda, and when you do this, you at first blush would expect it to get a purple or blue color because, well, I should probably do it this way so it's not backwards, because club soda contains basic salt, so you would expect maybe a blue or a violet color, but it turns red. What gives? Well, the reason why it's red is because there's a lot of carbon dioxide dissolved into water, and when the carbon dioxide dissolves in water, it puts a ton of acid in there. So that's why we have this red color. So the idea of the experiment is if we remove the carbon dioxide from the soda, will that allow us to see a color shift to more basic, because we're taking out the CO2 and there's some basic material left in the club soda. And I've seen this before, Josh. So as you do this, it already looks like there's a color change when you pour it into the
big time. Yeah, big
because
time.
you're losing the carbon dioxide as you pour it.
Well, not as big as I expected. Okay, it's all right.
Hey, I see people saying Bill Nye the Science Guy type beat. Guess what, folks? I met Bill Nye this past weekend.
Are you kidding me?
Very cool. Yeah. Oh, yeah, I did.
Where?
Okay.
What the heck?
So, I mean, it sounds cooler than it is. He was at Motor City Comic Con.
Come on.
Yeah. So I went and, I had a chance to talk to him for 3 seconds. There you go, Tara. Tara Chad. The chemist has entered the chat. What do you think, folks? Those look the same to you? Hey, I want you to do something. Reverse the 2 flasks. I want you to reverse the 2 flasks. Do it one more time.
They look different.
Yep, it's the lighting.
You think it's my lighting?
Wait a minute.
I
Reverse
don't
it.
think
I want to
so.
see if the redder color looks like it goes to the right. Reverse it.
Okay, here's this.
Yep. Okay, so the one on the right looks more red to me.
Yeah.
So I want you to test this, Josh. Take them out of view. Remember which one I said was red. Right now, the red one's on the left.
Yeah. This
Take them
one's
out of
redder.
view. Yep, take them out of view. So I can't tell. Mix them
Okay.
around and see if I can identify the one that I think's more red. If so, you all better believe me when I say there's color changes. If not, I'm full of crap.
Okay,
Yeah, the
which
red
one's
one's on
redder?
the right. I can already see it. The red one's on the right.
Yeah, it is the one on the right. Hey,
Yeah.
here, look at this one bubbling. I think this glass is maybe rougher or scratched on the inside because look at all the bubbles.
Yep.
Can you guys see that bubbling? So there's a lot of nucleation sites inside that glass. Let me get a different glass.
Hey, while you're doing that, Eucalypt is saying they lost their interest in chemistry a really long time ago, and now they want to reignite their interest in chemistry. How can you do it? Well, Eucalypt, what I would do is I would just start to study whatever you find interesting. I mean, that's it. You know, if you don't like chemistry anymore, we'll find out what you do like. And if you kind of still have an inclination for chemistry, well, what is it about chemistry that you really love? And pursue that. What do you think, man? I can see those bubbles coming out like crazy on the left. And that one on the left looks a little more red to me. We're
What do
having
you
so
think?
much trouble. What?
We got to get two that are the same color to start.
I agree. We got to get
Hey,
two that are the same color.
by the way, Dylan, this is your fault because we're going with your experimental design.
I still think I think the two on the end are pretty close.
Two on the end.
You agree?
There's our two.
Yeah, it's pretty close. Although to me, the one on the right looks a little more red.
Well, let's put that one in the chamber then.
Ah, good call. Good call.
Because that's got more acid. Let's put that one in the chamber.
Yep, agreed.
And I gotta
really close though. They're really close.
They're very close. I gotta prop that one up too because I don't like how it's a little bit lower.
So okay, TM is saying I'm not understanding how they could be different coming from the same bottle. That's a really great question.
Yeah.
So here's the issue. Here's why these experiments are so difficult to pull off. It's because the amount of carbon dioxide in the water affects the pH. And when the pH changes, the color is going to change. And so I think the difficulty we're actually having in pulling off this experiment is actually demonstrating what we're trying to demonstrate. And that's the fact that when you dissolve carbon dioxide in water, it changes the acidity. Well, we're gonna try to pull it off here. We're gonna try to pull it off.
All right. Here we go. Let's no more of this messing
Dylan,
around.
you get your screenshot? Dylan's taking a screenshot.
Oh, good idea, Dylan. You know that I want it to be perfect, and I'm just gonna have to live with it, aren't I?
I think we are. I think they're pretty good. I mean, they're really close. Really close. All right, Dylan got one. Tara Chad, advice. I don't know what GCSEs are, Tara Chad.
There we go. That looks good. Look at that. Okay. Are we ready? Should we do this?
I think we're ready. I still think the one in the chamber is more red.
Yeah, that's okay. I'm okay with that.
All right, baby.
Because
come on,
all right,
baby.
Here we go. I'm turning this on. All right.
Got a good
The
seal?
pressure's dropping. Look at it bubbling. So the pressure is going down. You can't see the gauge. All that CO2 coming out of there.
I see it. Color shift. Come on, baby. Look at that color shift. Come on, man. Look at that color shift.
Oh, it's going.
It's totally orange. It's like a yellow-orange now.
It's going almost yellow.
Yeah, it totally is. It totally is.
Come on. All right. That's beautiful.
I think it is. I think it totally worked. That may even may even be gaining a green tint, like a really slight green tint.
I mean, there's a lot of CO2 left. It's still bubbling.
Yeah, it's
So
still
let's see
going.
how far this thing will go.
Cute. You're right. We've got a lot of problems, but I think we've got it demonstrated. Looks like a Chardonnay, says Earthy. Hey,
Yes.
I'm giving this a thumbs up, but you don't have to. If you think there's been a color change,
Thumbs
do
up.
let us know in the comments with the thumbs up. Give us a thumbs down if you don't think there's a color change, and give me an equal sign if you're saying, no, there's no, I can't tell one way or the other.
What do you think of all these other ones too?
Zaj, pH 7 would be green. pH 7 would be green. Yeah, you got all the controls there. So we got,
Neutral, yeah, neutral will be pretty tough here.
TM says thumbs up. I got you, Tara Chad. Tara Chad, I would say try to find a way to make the study of the subject interesting to you. Zaj, thumbs up. Eucalypt, thumbs up. David, thumbs up. 1, 2, 3, 4. We got 6-0 right now. We got 6-0. I think it worked.
Yeah, that worked. All right, I'm shutting this thing
Yo-Yan,
down.
thumbs up. That's 7.
I won't let the pressure out right away. It does slowly return, but that what we're at right there is less than 10% of the air you'd find in normal conditions is left in there. So that's just causing all that CO2 to come right out of there.
Dylan says thumbs up. Lisbeth says thumbs up. Dylan's giving us a 4 thumbs up. I think the score is roughly 9 or 10-0 right now. Josh, I think the experiment's a success.
This is great. I've been wondering about this for a long time. I haven't been able to get it to work. And I owe you, Dylan. I really do.
Hey, make sure you're going to do a video on this, right?
Yeah, I'm going to do one on this.
Make sure it's Dylan Sterling. Make sure it's your channel. You do what you want. But I would suggest that you give him a call out in the video description.
Yeah, I owe you, Dylan. Dylan Sterling.
Absolutely.
Yeah, I'm going to screenshot so I don't forget. There we go. Sorry, everyone. So that's
there's
beautiful.
A lot of moving parts here. There's a lot of folks who contributed to this experiment for sure. I mean, you had the idea of using the warmer water, which I definitely think helped.
Warmer water helped, and I need a boiling stone or something in there.
That might help.
That was your idea, Tom. That would really help get it to go faster, I think, too.
Heck yeah. That is a lot of fun, man.
That's beautiful.
It really is. It really is nice.
That is nice. And there's the other one that we didn't put in there. But look at everything's a different color. What the heck? Is that redder?
To me, yeah. The one on the end's orange, red, yellow. I can't see the one on the far right because it's on my, the little tools.
Oh, yeah.
Just nudge it a little bit. Yeah, that one looks kind of like orange to me. A little orange, yellow.
Isn't that weird? Out of the same bottle.
Yeah.
And I think this one, you might not be able to see it very well. This one's a little more orange, and it has not stopped bubbling because I think this glass is just rougher on the inside, allowing more bubbles to form. Because I don't see the same bubbling forming there.
You just gave me an idea for a video now. So I have these, hold on a sec. Where are they? I have these beer mugs that naturally induce, like they have laser etched nucleation sites on the bottom.
Oh.
Yeah, I think you see where I'm going with this.
Yeah.
Yeah. Yep.
That'll be great.
Zad just saying a heat plate with induction mixture would work well. Very cool. Hey, how about I do this other demonstration that kind of shows how carbon dioxide dissolved into water changes the pH.
Yeah, do that. And I got my area's a mess here, so
right.
I'm gonna clean it up a little bit while you're doing this, and then maybe
we'll get her all set up over here, okay?
Yeah, and then maybe what I'll do at the end here is I'll throw some interesting things in my vacuum chamber. This is my little look at all I got all that stuff.
Come on, baby.
So maybe we'll wrap up with just tossing some stuff in there because it's pretty fun to watch things react to the pressure change.
Heck yeah. All right, we got to get some backlighting here. Everything looks better with backlighting. All right, folks, so just bear with me here. We're going to put this here. Let's see how that looks. Oh, yeah, that's going to look nice and pretty. That's going to look very pretty. All right. Now, I'll get in a little closer. And I'm going to do this too, so we can't quite see the light in the back.
You know,
It'll
Tom,
just look nicer. The colors will pop a little more.
Tom, there's a good question here from Tara Chad 23. In your graduated cylinder, it was red on top, but you know, it's acid on the top, but base on the bottom. They didn't mix.
Yep. Hey, Tara Chad, how about we talk about that after I do this experiment here? That's a really interesting experiment that we can we'll go over after this. All right, let me just get this one set up, and we'll take care of this, and then we'll head on over and do the other one if Josh is still working. So what I'm going to do here is into this flask, I'm going to add some Essentia alkaline water. This stuff is like a health hoax, but nevertheless, I like to use it because the pH of this stuff is fairly high. So I'm going to go ahead and pour this in here. Hey, welcome back there, Wall. So in goes the essential water into my flask. Do about 400. That looks good. And I'm going to add some universal indicator. Universal indicator is also known as rainbow indicator. It changes the colors of the rainbow depending upon pH. I got to find my little universal indicator squirter here. Yeah, here, we'll just give you an idea. Here's the universal indicator scale. So if we see red, it's an acid at pH 3. If it's like an orange, it'll be pH 4 or 5. If it's yellow, pH 6, and so on. If it's neutral, it's green. And if it's basic, it'll be like a violet or a blue. So let's go ahead. I mean, they sell this as alkaline water. Alkaline is synonymous with basic, so you can probably guess what's going to happen here. So let's give it a little squirt. Look at that beautiful blue color. Come on, man. That makes sense, huh? Makes sense. Hello there, Easton. It makes sense that we got a violet color. Yeah. Because they sell this stuff as alkaline water. Now they'll say this stuff alkalizes your body, which is complete BS. Let me show you why. What I'm going to do is I'm going to breathe a little bit of carbon dioxide in here. And let's see how long it takes my body to neutralize. Here's our colors to neutralize the alkaline water. Okay, here we go.
Wow.
By the way, the reaction between carbon dioxide and water and base in the water is very slow. And all of the carbon dioxide I was exhaling was not going into the water. I was missing quite a bit. So the amount of carbon dioxide it took to neutralize this stuff is exceedingly low. Now I'm going to keep blowing. I may be able to pull this to a yellow color. Let's try here. Maybe. I get there, Josh? Is that yellow? Sure is.
Yeah, I call that yellow. It looks pretty good.
It's got a tint of green to it, but it's definitely yellow. How about we do this with some dry ice?
Yeah, if you have dry ice, let's do
got
that.
some dry ice. Of course, I got some dry ice. We're doing all sorts of experiments with carbon dioxide, water, and all this jazz. So let's do a little bit with some carbon dioxide. Yeah, that wasn't even one full exhalation there, Zadge. Not even one full exhalation. But I got some massive lungs for an old guy. Here we go. We're gonna put in a little more essential water. In it goes. And we're going to add dry ice to this. Now, the reason why I'm adding dry ice is because dry ice is carbon dioxide. It's just solid carbon dioxide. And when you add it to water, it changes to gaseous carbon dioxide. Dry ice, baby. All right, let's add our universal indicator, which will, as we remember, that should turn to a violet color at pH 9.5 or 10. Oh, that's gorgeous. So pretty. So absolutely pretty. Give it a swirl.
Yeah,
I
it
gotta
looks
put my
great.
gloves on. Let me see the lighting here. Does that look
That one.
better or worse?
That one right there. That's a
You
good
like
one.
that? Okay.
Yeah, that's good.
I'm gonna just pull it up just a bit.
Walt wants some dry ice. You gotta give this person some dry ice.
All right, Wall. Give me a second here, bud. I gotta
How
get
cold
my
is
glove on because
how
it's.
how cold is dry ice, Tom?
Well, it depends. You want me to answer like a true American patriot?
Pretend you're talking to a Canadian right now.
I'm talking to a Canadian. It's negative 78.5 Celsius, which is
That's
the
cold.
same freaking way a true American patriot would answer the question. Oh, well, maybe Kelvins. You know, we'd use Kelvins too. So that's
Yeah,
196 Kelvin.
20, well, I say 200 Kelvin, but I always round.
Okay. All right, let me get some of this dry ice out. Ah. Oh, dry ice is so fun to mess with. Hey, it looks like Dylan's got a Canadian.
Dylan,
Come on,
all
baby.
right, there we go.
I mean, hey, I'm from Michigan. I'm half Canadian. Just you know.
Yeah, well, and I reside in Michigan now, anyway, so
Yep. Yep.
I can do
Okay.
both. I can do Fahrenheit. I can do Celsius.
Here's our dry ice. I'm
There it
holding it
is.
with gloves. Yeah, I'll probably put a little light on this so you can see a little better, and then I'll take it back off. There, you can
Yeah,
see
I
it.
can see that.
Yep.
Yeah,
All right, here we
if you
go.
grab that with your bare hands, though, you're
Heck
gonna get
no.
hurt.
Ready? Here we go. In it goes. As the carbon dioxide bubbles through the solution, it really quickly changes it to a acidic
Beautiful.
pH. And that actually is getting a little bit of an orange tint to it. It's pulling the pH quite low.
Thanks, Earthly McLiving. Appreciate you.
Hey, this is a little fun. Let me add a little bit of base to this, Josh. Why not, huh?
Yeah, put it back to blue.
Well, I'm not sure I'm gonna be able to do that. Hey, by the way, this is a
Oh,
tag team live between myself, Tommy Technetium, and Josh from the Science Channel. If you've not followed Josh on the Science Channel, it's something that you might want to do.
here. This
Go ahead and
I
check
keep
him
meaning to
out.
put this on my chamber here so you can see that.
There you go. Dylan's asking. There you go. Yep, Dylan. It's
There you
the
go.
Science Channel. Hey, and you recently reached a pretty cool milestone, yeah?
Yeah, I just about a month or two ago, I finally hit 100,000 subscribers.
Come on, baby! 100,000.
So
That's so awesome.
that was huge. I got the silver play button,
You got it
and
down there in the basement with you?
I don't I don't have it right here on me,
There you
but
go,
that was
Isaac. Here's your chart. Here's your chart. Sorry, it's not like, small enough to stick next to the beaker, but we're at like a pH of 4 right now. That's fairly orange. So what I'm going to do right now is I'm going to add a drop of base, sodium hydroxide base. Give that a quick swirl. Oh man, it neutralized it for a second. I'm gonna have to add a bit more base to see if I can get it
yeah. You
back to
need more
purple. Here we
base.
go. 1, 2, 3, 4, 5, 6, 7. I got it to
Woo,
purple.
beauty.
And as the carbon dioxide bubbles through, it pulls it back down.
I love that blue color it makes. Right after the purple, that blue is
Yeah,
really
it
pretty
is.
color.
It is pretty cool. Oh, look at there. We're going to yellow again.
Nice.
Now it's going to be a little tougher to pull it to pH 4 or 5. How you doing there, Huddy? Good to see you. Good to see you. Hey, Josh, something that's cool that I want to talk to you about with carbonic acid. This is a common misconception
Okay, tell
that
tell
I
me.
didn't know until just a few years ago. Here's the common misconception. It's pretty wild. I'm gonna put another. We'll put this flask up and we'll put some dry ice in this one.
Yeah.
So, did you know that carbonic acid does not exist in solution? So H2CO3 does
Yeah.
not exist in solution.
Okay. Because it's free ions.
It
or what?
immediately dissociates into hydronium and bicarbonate.
Well, hold on.
I know
Isn't it a weak acid though?
it's considered that, yes. But the weak acid is actually carbon dioxide.
So it's a Lewis.
It's a Lewis.
It's
That's right. I think that's right.
a weak
Lewis.
Lewis acid.
Lewis
Is
acid.
that even
Yeah.
a thing?
Huh?
Huh.
So
That's
here's
a
the
thing.
deal. Here, let me put this in here. Here's the deal. I
Yeah.
mean, okay, they can detect it in solution, but it lasts like 300 nanoseconds or something like that.
Wow, I did not know that.
Oh yeah, they can detect it in the gas phase. They do see it in the gas phase, but it does not exist in solution. What is the universal indicator and what's its method of action? All right, Dylan, this is going to take a
That's
little
a good
bit.
question.
So here's the deal with universal indicator. I'm going to simplify it a little bit. I'm going to complicate it first. So universal indicator is actually made of 4 different dyes, and those dyes happen to be thymol blue, which shows this pH response, methyl red, which shows this pH response, bromothymol blue, which shows this pH response, and phenolphthalein, which shows this pH response. How you doing there, the administrator? Good to see you. What happens if you drink it? I'll tell you what happens. The live ends in about 15 minutes because this component of universal indicator used to be the main ingredient in X-Lax. So I think you can figure out what would happen if I drank it. We're going to focus on phenolphthalein. All right. We are going to focus on phenolphthalein. The others act similarly. Okay. But I hope you see how if you add all 4 of these up, you get the rainbow response. But we're going to focus on phenolphthalein. We're going to talk about this at, kind of the molecular level. So here's the way phenolphthalein works. If there's an acid, there happens to be a lot of a chemical species called protons around, which I'm going to symbolize by this H plus on this bottle cap. When phenolphthalein sees an H plus molecule, it grabs onto it like this, and it makes a ring. This is representative of the ring in phenolphthalein. And when phenolphthalein has this molecular structure, it's colorless. Now, when bases come around, bases steal those protons from phenolphthalein. They take them away. And when that happens, the phenolphthalein goes doink like that. It pops open. And with that change in molecular structure comes a change in color from colorless boop, to pink. And that's why phenolphthalein is colorless at low pH where there's lots of protons around, and pink at high pH where there aren't many protons around. The other indicators act in a similar fashion, but describing all of those details is going to take way too long. And that just gives you a basic idea, no pun intended, of how phenolphthalein changes to pink in a base. Can I break down the acid conversation in kids' language? Oh, I'm so sorry. I thought we were doing that, to be honest with you. I thought we were. Oh, you're welcome, Dylan. You're welcome. I think Dylan got it, but sometimes it's a little hard to do this without a chalkboard for sure.
Yeah. Tom, I'm just setting up some things here. Just if you're wondering what I'm doing.
Hey, administrator, sure, yeah. Administrator's got a suggestion for a video for me. Run it by me, administrator. What do you got? Hey, great to hear, Event Horizon. I hope the exam went well for you. Hello there, Armand. We are setting up a second set of experiments over there on the right. Can't wait to see it, Josh. So the physical structure of the molecules themselves dictate the refractive index of light directly. We're not going to call it the refractive index. We're going to say the way it absorbs light. I think refractive index, that talks about how fast light penetrates the medium. Slight difference. But yeah, same idea there, Dylan. Same idea. Thank you there, Isaac. Those peeps are about to become elite. You let me know when you're ready to go, bud, because I want to turn around and watch this. Looks like my solution is roughly the same color as some of your peeps.
Yeah, look at that. These are leftover. I don't know if they have these outside of the States, to be honest. If you live in the United States, you're probably familiar with these, but most people at least know marshmallows. Marshmallows are probably my favorite thing to put in the vacuum chamber because they're full of air. And it's kind of they're like little balloons. And inside this vacuum chamber, what happens is that the pressure will go down. We're going to drop the pressure, and the volume of gases goes up. They expand. So when pressure decreases, volume of a gas increases. So anything with a bunch of air, like marshmallows, will get bigger. So it's really fun to put in there. Some of my other favorite things are Twinkies. Maybe another American thing. They have them in Canada too, I think. But Twinkies here it's a cake, and inside is a creamy filling that's whipped, so also full of air, kind of like the marshmallow. So basically, for the Twinkie, the inside of the Twinkie expands, but the outside does not expand because the cake is porous, and so the air can just come right out of the cake. It's not like it's trapped. It's not trapped. Whereas the cream, it's kind of trapped in there. So, are you ready for this, Tom? I'm gonna do this.
I'm ready. I just want to make sure I understand what's going on here. You got some. What's in the chamber?
I got some peeps here made of marshmallow.
Peeps? The blue peeps.
Blue peeps. I got pink peeps on the outside. I just thought I'd put. These guys are watching. What's the front of a peep? Is that okay? There, those peeps are gonna watch their friends.
I love it.
All right. We got some regular marshmallows over there. Then we got our Twinkies. I got one Twinkie inside the package, one Twinkie outside the package, because I haven't done those side by side. I'm kind of curious of what's going to happen.
Okay.
All right. Ready. Let's do it.
All right. Let's do it, baby. Let's see what happens.
There we go. Man. Pressure's dropping. Look at those. Look at those peeps.
Those marshmallows are growing, man. They are. Look at that. Holy mackerel!
You see how big they get?
Here, I can't even see the Twinkies anymore.
Look at that Twinkie.
Oh, the one Twinkie is exploded.
Yeah. What do you think, peeps?
I think they're glad they're not in the chamber.
Now, the really fun part, and this is more physics, this part, I think. But once we get all the air out of those marshmallows, they start to collapse, even while the pressure's low.
Huh.
And I think there's the elasticity maybe in the marshmallow kind of causes them to rebound a little bit.
Yep.
But once all the air's gone, when you bring that pressure back, they get crushed down to nothing. They really get a lot smaller. So I'm going to give it another minute because I want to make sure I get all the air out of those things.
Okay.
And then make sure these peeps have a good viewpoint here. Yeah, Action Lab did some of this. All right, fair enough. Not everything I do, though.
That's right.
All right, here we go.
Go for it.
Crush them.
Look at that, man. It just totally shrunk. What do they taste like?
So look at that. Look at that peep.
Holy mackerel.
Compared to these guys that were watching.
Look at that.
So with air, and that's a peep without air. And then the marshmallows, they get they get really crushed down. Where's my marshmallow? Awesome. So you can see before the after. So this marshmallow with air, there's still some air in there, but not much is left.
Hey, check out the Bolts comment. The pink one on the far left looks like it passed out.
The Twinkie does just fine, to be honest.
Yep. That's cool.
I really like Twinkies, actually.
So what's your favorite vacuum chamber experiment you've done so far?
Yeah, my favorite was my drone
Oh yeah, that
vacuum
was
chamber.
cool. That was cool. Yep.
That
Yep.
one was really fun. And I bought a bigger vacuum chamber just for doing that experiment again, and I haven't done it yet. It's really hard to fly the drone in there, but I'm working on another one
Okay.
to test at different elevations and see how high
Yep.
the drone could fly.
That's cool, man.
That'd be pretty cool.
That is really
And
cool.
one that's going to come out in a couple of weeks is I filled my vacuum chamber up with water, and I put a little boat in there, a little remote control boat, and because I wanted to see if the boat could still drive when the water started boiling.
Ah.
And so I got the water boiling, and boats don't drive very good in boiling water. That's what
I bet not. I bet not. Oh, that's cool. And you say that's coming out in a couple weeks?
That should be out in a couple weeks. So you guys, Tommy Technetium, but this is me. I'm the science classroom.
Yeah, make sure you make a follow, folks. You got to head on over to the science classroom and give Josh a follow. He does a lot of cool stuff with vacuum chambers. He also does stuff like if you're trying to learn various topics in science, he has a lot of tutorial videos that people tend to like too.
Yeah. Dylan has a question here, and Tara Chad. Yeah, no, you're right, Tara Chad. There's a lot of air that sits on our shoulders, and it's a lot of weight. What is it, like a ton of air? If you consider all the air in the atmosphere that's kind of pushing down on you.
You know, I never knew that. I don't know what it actually is. Huh? Like a ton of air. That's crazy.
There's a calculation you can do if you take a meter squared or something like that
Yeah. Yeah.
as your the area, and then the
Oh, I see. That's how you do it. I see.
yeah.
I was thinking, well, I guess it would have to be the same as the other calculation I was thinking. So yeah, it would have to be. So you
Yeah,
think
Dylan.
yeah, that's about right. I suppose our body area is about a meter squared.
Yeah,
Thanks
it's
there,
rough,
TM.
but
We appreciate that.
yeah.
Hey,
Um,
my battery is dying quickly, so I think this double streaming is totally eating up my phone, man.
yeah,
It looks like we
this,
get about an hour, and that's
this is
usually
pretty
how
good.
long. That's usually how long I do my lives anyway. So,
So I do 15 minutes, so that's
oh, do
pretty
you?
good.
Okay. Well,
Yeah, that's
cool.
good.
So
Well,
we need to
Tom,
do this again,
thanks.
Josh. Yeah.
Yeah, thanks for having me on. This was a lot of fun. Thanks for all your followers for
Yeah.
joining this.
Yeah.
Are there any of my followers, or is it all your? I don't know. Did you guys?
I have no idea. No
It's
idea.
our first time doing this, so
Yeah. 1.6 million moles of air, maybe. That'd be a lot of air.
that's a lot of air.
Well,
Yeah,
thanks for
I don't
joining
know.
in, Dylan. We appreciate it, and thanks for
All right,
your suggestion and correcting this PhD chemist. I always enjoy learning something new and getting corrected. It means I learned something. It's great to be wrong, baby. When you're wrong, it's the only way you can make yourself right. I
that's
should be
right.
careful. When you're wrong and admit it, that's the only way you can make yourself right. Yeah? Sure enough.
I'll take that. Yeah.
Yeah.
All right.
All
Thanks
right,
again,
Josh.
Tom.
Make sure you make a follow to the Science Channel. Thanks, folks, for enjoying some of the beauty, wonder, and fascination of science with us today. I usually do lives on the weekend. I'll probably be doing one sometime this weekend. Who knows when? Maybe Josh and I will pair up again. Who knows? But thanks for hanging out. Josh, thanks for being here. And we're going to see you all next time. All right. So long, folks.
Bye, everyone.